So this video is about interpreting different parts of an expression, and before we get into this, I wanted to clarify one little thing about algebra. So in algebra, we have expressions and then equations, and there actually is a difference. An expression is almost like a mathematical sentence. It's like what you were writing in the last lesson. Any of these would be an example of an expression. But an expression does not have an equal sign. If you have an equal sign, that makes it an equation, as in like equal, equation. So as soon as you have like two sides to an equation with an equal sign in the middle, that is an equation. So this is an expression, and that's an expression with an equal sign in the middle. You can't solve an expression because it doesn't equal anything. Like x here could be anything. I could put in anything I want for x, but as soon as you have an equation, then I can usually get x by itself or solve for x or figure out what x needs to be to make this equation true. Okay, so let's look at some parts of an expression. And this is vocab that you're probably familiar with, but we need to review a bit. So you've got variables, and those are just all your letters, things like x and y. You've got coefficients, and these mean any number that's written directly in front of a variable being multiplied by the variable. So 2 is a coefficient and 4 is a coefficient. It's called coefficient because co means like together, like cooperate. So it's co because it's together with the variable. Whereas a constant is a number that's by itself. It stays constant, it never changes. It doesn't have any variable to change it, it's gonna stay constant. So the -9 here is a constant. And then of course we have terms. 2x is a term, 4y is a term, -9 is a term. Terms are anything that are separated by plus or minus, and it could be a number, like 9, it could be -9, it could be a number and a variable, or it could be just a variable, but any of those could be terms. Okay. So here's a definition for term if you want to write that down in your notes. A term is a number or a variable, or a number and a variable multiplied together. Again, they're always separated by a plus or a minus. So what we're going to do is do a couple examples of just some sort of real-world context that's being represented with algebra, either an equation or an expression, and talk about what do these numbers and variables mean within this context. So for example, the cost to rent a car can be represented by this equation here. I'm assuming C means cost. 100 plus 0.5 times M, and M is the number of miles you drive. So that's what the variable represents, the number of miles you drive. What does the constant represent in this context? So first, let's go find the constant. That's 100. So I know that the constant is 100, but what does that mean? Well, in this context of renting a car, you may want to try a few examples, like just to see what's going on here. Like, for example, if I drove 20 miles, I put 20 in for M, what would happen? I would do 100 plus 0.5 times 20, or 100 plus 10, which is 110. That means if I drove 20 miles, I would have to pay $110. That would be the cost to rent the car. Let's say I drove 50 miles. So 100 plus 0.5 times 50. That would be 100 plus 25, which is 125. So it's going to cost a little bit more money if I drive a few more miles. So you can kind of see what's happening here is this 100 is an initial amount that I'm going to have to pay. So that's what the constant represents, is no matter how many miles I drive, I've got to pay like a base 100. So I'm going to put that it's a $100 initial fee to rent the car. You may describe that a little differently, but that's basically the gist. No matter how many miles I drive, I've got to pay that $100 fee to rent the car. And then what does the coefficient represent in this context? The coefficient is the number that goes with the variable. That's the 0.5. So what's happening with that 0.5? Well, every additional mile, I'm having to pay another 0.5 of a dollar, or 50 cents. So I'm going to put, I have to pay an additional 50 cents, or 0.5 of a dollar, for each mile driven. Whoops. For example, like when I put in 20 miles, I ended up having to pay 10 extra dollars. It's always another 0.5 for each additional mile. Let's take a look at a quite complicated example. So take a second to read through that. I'm going to make some notes of what's happening here. So this is truck 1. It says it can transport X yards cubed, or cubic yards. The second truck can transport Y cubic yards. So instead of numbers, it's just giving us variables, and that's okay. It's just standing in place of the numbers that we might have. And the first truck makes S trips. So that could be like 4 trips or 5 trips, just whatever S is. The second truck makes T trips. So this is how many is just in one trip times the number of trips that we take. Like say it could hold 50 cubic yards times 3 trips, that would be 150 total. All right, so let's interpret each of these. This is not multiple choice. We're going to interpret each one of these. So like, what is S plus T? S plus T is the total number of trips that truck 1 is taking plus the total number of trips truck 2 is taking. So S plus T would be the total amount of trips for both trucks. X plus Y, well, X is how much truck 1 can hold. Y is how much truck 2 can hold. So X plus Y would be how much both trucks can hold on one trip. All right, X times S is if you take however much truck 1 can hold times the number of trips. So that would be like the total amount of, what are we doing here? Sand. We're transporting sand. So that would be the total amount of sand that truck 1 could transport total, and then YT would be the same thing but for truck 2. So if you add those up, that would be the total amount of sand that we can transport after all the trips have been taken. Finally, this takes the total amount of stuff that we did, the total amount of sand that we can do in like a day, and it divides it by what we got up here, which was the total number of trips. So if you divide all the sand total divided by the total number of trips, what that's actually going to calculate is the average amount of sand being calculated per trip, because it was the total sand divided by the total trips that would give you an average of sand per trip. So I'm not going to write that out. Feel free to rewind if you need to hear any of that again, but that is the end of that problem. Just a couple more. Benny wants to put a rectangular fence in his yard, and he wants, let's draw a rectangular fence. it says he wants the length of the fence to be 5 less feet than twice its width. So let's write an expression for that. 5 less than means take 5 away from this, twice its width. So I do twice its width, and then I'm going to do 5 less than that. So twice the width and 5 less than. So if this was the width, this could be the length. Twice the width minus 5. He also found every foot of fencing will cost this much. The total cost of fence would be this, where W is the width of the fence. So what does this represent? So take a second and pause and see if you can figure out where that's coming from. So I'm guessing if I'm doing this, which is the cost per foot, I'm guessing that this is going to represent how many feet I have of fencing total. Like if I have this much fencing times this, which is the cost per foot, that would give me the total cost. And so that's what this represents, is the total amount of fencing that I need. But where is that even coming from? It's coming from this that we just came up with. I've got 2W minus 5 here, 2W minus 5 here, WW. If you were to add these all together, you would get 6W minus 10. So that's where that's coming from. But it represents the total amount of fencing that I'll need based on what the width is. Last example, Kurt's car gets 23 miles to a gallon of gasoline. He fills up his car's gas tank with G gallons. Write an expression that shows how far he can drive. So if he gets 23 miles per gallon times the number of gallons, that's it. So for example, say he had 10 gallons in his tank. That would be 23 times 10, which is 230. And that's how far he could drive in miles. But all it asked was to write an expression that shows how far he can drive, and we don't know how many gallons it holds. So we're just going to put G for gallons. That's the whole point of algebra, is we can just use letters to represent unknown things. So there we go. It helps me when I'm working on this kind of thing to think of examples. So if that helps you, like for example on this one, I might think about, well, if I got 23 miles per gallon times like 10 gallons, how much would that be? So that could be helpful to think through some of these.